Example 6. Use partial fraction decomposition to investigate these graphs. So the first thing we have to do is the partial fraction decomposition.
BT dubs.
Yes.
This is actually really cool.
Yeah, it is. But spoiler alert, right? It won't be really cool until we show them at the end.
Right.
Okay?
Right.
So the first thing to note here, this whole time we've been telling you. Okay, we need a code word.
How about spoiler alert?
Okay, code word, spoiler alert. So don't forget to type that in. Don't tell anybody else or you'll have spoiled the spoiler alert.
Yeah, top secret.
Okay, this whole time we've been saying, hey,
if you tell somebody else, I'll tell you how the divergent series ends.
Ooh,
okay.
That's tricky. Okay, this whole time we've been saying, check the degrees. They're the same degree, so that doesn't work. We have to start this off by doing long division.
But that's okay, because this long division, it's okay to have long division. Don't be afraid of long division.
This is some of the easiest long division of all times. You start off by saying, what do you multiply x squared by to get 2x squared? Okay, so I'm going to stick that over here because it goes above.
You got to keep everything in the same path
So now we do 2 times x squared and change the sign because we're trying to subtract. We do 2 times -4, which is -8, but we change the sign. Do opposites. So x gets to come down here to the bottom. -14 plus 8 is a -6.
You're done.
Okay, so 2, and then to write our remainder, it's x minus 6 over what we were dividing by, which is x squared minus 4. So now this 2 is going to hang out, like it's part of our answer. Okay. And then we need to break up x squared minus 4. That breaks up into x plus 2 and x minus 2.
Right.
And now we're going to do partial fraction decomposition on this right here.
Right. So.
Which should not be that. This one's not that bad.
No, this one's actually pretty reasonable. There's no irreducible quadratic fouling things up.
So we'll do just our first method way. And in a lot of ways, it's not really which method do you like more. It's which one is easier to use in this situation.
Yeah. Fewer steps, as it were.
So for this one, we need an x minus 2. For this one, we need an x plus 2. Okay, we know the denominators are going to go away.
Right. Now, I was going to say, notice Mrs. K. Steve here just filled in the numerators because we know the denominators are all going to be the same.
Now, what 2 numbers should we pick to plug in?
I know this. Don't tell me. It's going to be 2 and -2.
Right. So I'm going to start with 2. 2 minus 6 equals a times 2 minus 2 plus b times 2 plus 2.
Right.
So that's
the a guy is gone. I wanted to do
4. So that's 4b. -4.
So b equals -1.
And then now we're going to plug in -2. So -2 minus 6 equals a times -2 minus 2 plus b times -2 plus 2.
So, whoa.
This time,
this time, right.
You ready? Pew, pew. Okay, so this is -8 equals -4a. So you divide both sides by -4 and get the a equals 2. So now in our answer we have 2 plus, remember, and then we have a, which is 2 over x plus 2, and then plus -1 for b over x minus 2. And again, you can write this as minus and then not have the minus on top.
Right, it's up to you.
This is
but you only need 1 minus.
Right.
Yeah, you don't.
This is our partial fraction decomposition, and then the next thing it asks us is to compare the graph of the rational function with the graphs of the terms of the partial fraction decomposition.
Which is the partial fraction decomposition. So.
Right. So what it wants us to do, this is one of those moments where it wants us to look at the graph and be like, oh. It's not like write stuff down. This is a learning observation.
Right.
So you've got all this written down. If not, you need to pause because I'm about to take it off of the screen. So and actually, let me save this part. Check out how cool I am.
You're cool.
All right, so we graphed this earlier. This is the graph of the original function in red.
Yes.
And then 2 over x plus 2 is...
in green.
In green. And then -1 over x minus 2 is in red or something to that effect.
Right.
Okay.
Blue.
Yeah, blue. blue. Maybe we
The other
should
way
write this
around.
down.
2 over x plus 2 is in blue.
2 over x plus 2 is in blue.
And negative 1 over x minus 2 is in red.
Okay. But it really doesn't make a huge
It
difference
doesn't. It
which
doesn't.
way it
But
is.
for
But-
what we're going to talk about, it doesn't make a difference.
Right. So
Yeah.
this is what we want you to notice. Sorry. The original.
Did you just kick
sorry.
me under
no,
the
sorry.
table?
The original function in red. White. You meant green, right? Green.
What did I say?
You said red.
Well, it
The
wasn't
original
accident.
function in red. Okay. For one thing, this 2 in front means that our green and our blue graphs have been shifted up twice. But if we add these two things together, notice how this looks like
really similar.
our parabola.
Yeah.
And then we've got this section right here, which if you shift up to, looks like the red graph.
Right.
And we've got this part right here that if you shift up to, looks like that graph. So that's kind of neat that you can graph the parts separately and see the
The actual whole thing. Yeah. It's kind of cool.
Kind of cool.
Kind of neat.